this lesson, lesson 4 for today on Virginia ag erosion categories and characteristics is really important. And of course, we're focusing on cropland. And I mentioned that because it's possible that you might have a little bit different perspective if you're looking at pasture. But Russell 2, right? If you're learning about Russell 2 is for assessing sheet and rill erosion and organic matter trends on cropland. That's what we use it for in Virginia. And so obviously this is going to be our focus. All right, what are we trying to do today? Look, there are 4 categories of ag erosion that I'm going to talk about. And the first is sheet and rill erosion, right? And this is a pretty unique picture because it's often very hard to see good evidence of sheet and rill erosion, but this is a good picture of it after the fact. This is a gully. You've already heard a little bit about this gully or seen some pictures of it. And there's also some sheet and rill erosion in this picture, but we'll focus on the gully, right? These 2 forms, 2 categories of erosion we're going to talk about. There's also wind erosion and tillage erosion. You notice those pictures a little bit smaller because they're really not as important when you look strategically at cropland erosion in Virginia, but we want to talk about those. And what I want to highlight here, why are we talking about this? Well, if you're interested in Russell 2, you need to understand these different forms of erosion. First of all, you need to understand that Russell 2 only assesses sheet and rill erosion. All right. It doesn't assess the other form of water erosion, gully erosion. So we're going to have to understand enough about the 2 of them to know where Russell 2 applies and where it doesn't. And then you also want to keep in mind tillage and wind erosion because there are also forms of erosion out there. You cannot count on Russell 2. You can be a wizard in Russell 2, but if you're not thinking about these other forms of erosion, you're not doing your full job, right? So here's some questions for you, some questions that this lesson will hopefully arm you to answer. Why do we need a tool like Russell 2 to assess sheet and rill erosion? Where does sheet and rill erosion occur in the landscape? Right? And therefore, where does Russell 2 apply in the landscape? Where does sheet and rill erosion not occur in the landscape, right? And that's, you'll see that is a key question. There's some parts of a field where Russell 2 isn't relevant, and some parts where it is. So when, how, and why does sheet and rill erosion occur, right? What does that tell us about what Russell needs to know? And then what, as conservationists, what do we need to know to help prevent it? Some other questions for you on other forms of erosion, right? The other 3, when, where, why, and how do they occur? How do we assess them? How do we prevent them? And then, what does this tell us about the limits of Russell 2 and the importance of being a planner, not a robot? And I already alluded to this. You can be a wizard in Russell 2, but you are not a conservationist yet, and you are not adequately addressing erosion because there's far more to erosion than what Russell 2 can do. So I asked you those questions, right? And I'm going to try to cover and explain the answers, but the answers are actually in, they're in this chart, right? It's a 2-pager, right? So it's 2 sides of a page, 1 sheet of paper. I created a chart on Virginia NRCS cropland erosion categories and characteristics, right? So these 2 charts pretty much spell it out for you. This erosion categories and characteristics chart, it's here, right? It's here in the Erosion Resources Index. This chart, which has the answers essentially to the questions I posed, is at the index, and you could get it right now. I did not post it to the chat, but we'll take a closer look at it. And the idea here is I'm just going to walk through these tables and explain these tables, but I'll also follow up with some images to help you, and maybe even some video clips to help you understand what's going on. So look, the first table, all right, it's just comparing the 4 forms of erosion that I showed you in pictures before, right? The first row here is about wind. Then we have what I'm calling tillage erosion. We'll talk about those briefly, and then we'll dive into water erosion. But really, this table is useful for just contrasting in a general way these different forms of erosion. So wind erosion in Virginia, obviously the agent, the energy source that detaches the soil and moves it is intense wind. It is of concern in the coastal plain. Notice only the coastal plain. So that's a comparison with the others, or a contrast with the others. So wind erosion is a coastal plain issue, and it's a concern on flat, large, open fields, soils with low aggregate stability, especially sandy soils, we'll look at here in a moment. Key risk factors: strong wind, obviously dry soil, especially in the winter, right? And after it occurs, like the next day, can you tell how much soil was lost from a wind event? No, you can't measure it, and you can't really tell. I mean, you see some evidence the next day, but typically you can't. We do have a tool. The wind erosion prediction system is a parallel to Russell 2 for assessing wind. It's more complicated and harder to use than Russell 2, but if we have to use it, we can. And T, right, is our soil loss, is our soil loss performance target, right? The minimum target we expect for sustainability is T on wind. So that's, gives you a sense of what the chart is about, and then we'll go back and talk about tillage. But let me show you some pictures of wind erosion and a couple points about it. These are traditional areas of concern for wind erosion in the United States. Well, a lot of wind erosion is right here. Why? This is the first point, is that you've never driven down a road right after a dirt road after it rained and seen dust blowing, right? Soil won't blow if it's dry, if it's wet, right? So wind erosion is associated with dry climates and dry times. And, the Dust Bowl is famous pictures. This is 1935. This is the day they thought the world was coming to an end out there in Dodge City, Kansas. Right, but this is a more arid region, and the Dust Bowl was associated with a drought period. Here's New Mexico, another dry region in the country. This gives you an idea, the guy standing there, how much soil was lost from wind erosion. That's what we call a pedestal. But a lot of this stuff's still going on. You go on YouTube right now, there are a bunch of course, crazy winds in Kansas and Colorado last month, and there's some crazy YouTube videos of guys driving in it and huge billowing dust storms. But here's some pictures I happen to have from a colleague in Texas, February 2007, the before, right, and the after, right? So this is still going on out there. But what about here, closer to home? Well, we see that there's a region of our country that includes Virginia, which is an area of concern for wind erosion. Why? Why does it happen to be here? Well, what's different? Is this drier? Not a drier climate. Is there more wind energy? Well, maybe there is, especially here on the eastern shore. But there's something about this region. Oh, this is a coastal plain, right, where we have sandier soil. So one risk factor, in addition to strong winds, in addition to wide open fields where the wind is uninterrupted, a risk factor is sandy soils. They have low aggregate stability. They tend to fall apart easily, right? So if we have a lot of tillage, bare soil, coastal plain, we're setting ourselves up for wind erosion. So here's Isle of Wight County, and we see a lot less wind erosion in mainland Virginia now. We have a lot less heavy tillage crops like peanuts, and a lot of our crops are grown with some residue, but there's some example of wind erosion. Still, the eastern shore is a hot spot. I think this field actually has a cover crop planted on it, but the cover crop didn't do well. And so this is wintertime erosion. You can see there's snow out here. So it's these dry periods in the wintertime where we have uncovered fields on the eastern shore. We get wind blown soil. And anyway, another picture. So top take homes, it's really only concern the coastal plain, especially eastern shore, but it can be a real concern there. Problem, big bare fields. It's generally easier to beat than sheet and rill erosion. So, if you can think about it, it is, anyways, relatively sparse standing residue can really protect the soil from wind, where a sparse residue can't protect the soil very well from rain. Now, there's some plants growing in that field that I showed you on the eastern shore, but those are not tall plants. So if we have standing residue, and it's sparse, it can actually help us a lot. It's a whole different issue to intercept wind than it is to intercept raindrops falling vertically. Same management principle apply. You want to stop erosion by wind, keep the soil covered on top, sponge underneath. And I mentioned WEPs. If you ever want to use it, we can talk. But we're really focused on Russell 2, because if we're doing well on erosion prevention on the coastal plain, if we're doing really well in Russell 2, then I can already tell you we're going to be fine on wind erosion, because water erosion is harder to beat in Virginia than wind erosion. So that kind of covers wind. What about tillage? Maybe very, very brief on tillage. This is a form of erosion many of you haven't heard of, and I only would show you one slide, but it goes to this idea that soil can move downhill even in the absence of rain and in the absence of wind, okay? It's not an NRCS official resource concern even, but it just, in this book that I mentioned to you before, Building Soils for Better Crops, there's this image which highlights the idea that, tillage erosion is a real thing. If you farm up and down the hill or even on the contour, if your machine lifts soil, it will come to rest further downhill. That's just inevitable. And so yet another form of erosion Russell 2 does not account for, but you need to be thinking about, right? And we keep going back to this idea, as a planner and not a robot, when you see a lot of heavy tillage on a slope, Russell says, you're just passing. You're okay. You're meeting T or 2T, whatever your goal might be. There's probably some of this going on too that Russell doesn't know about. And so you may want to be a little bit more conservative and protective in some of the decisions you make and interpretations you make. But that's tillage erosion, right? We can now get into water erosion, right? And so I want to highlight in the next 10 minutes here some key concepts about the different forms of water erosion. So you can see sheet and rill versus gully, and there's two forms of gully. But this table doesn't really help you understand some of the most important distinctions between sheet and rill erosion and gully erosion. It's really good for comparing to wind and tillage. A couple points, we mentioned T, if you look in the last column, official NRCS planning criteria or performance targets, and then official NRCS assessment methods. One of the things to highlight, Russell 2, right, is all about the sheet and rill, right? And we have a planning target. It's not necessarily, it's not a target for regeneration, just for maintenance, right? Just for sustainability, I guess, conservation of T. When it comes to gully erosion, we don't have a prediction model. We use visual observation because it's something we can see. And then what is adequate? It's control measures in place, right? We don't want to see active head cutting, widening, or active gullies. So really a whole different approach to how we assess them. So here's the second page of this chart, which you can download. And let's highlight a few things, and then I'll show you some of the pictures. When we talk about sheet and rill erosion, first of all, we can divide it into sheet and rill. What is sheet erosion? It's a uniform sheet of soil removed from the land surface, right? Whereas rills, we have small channels, and you'll see parallel channels usually running across a slope. Gullies down here are channels that are washed in a drainage way. And that highlights this very, very important point. The key distinction between sheet and rill erosion and gully erosion. And sometimes in the field, it's a little bit hard to tell, sometimes it's a little hard to tell which is which, but it's where the erosion occurs in the landscape is the key to differentiating between sheet and rill erosion, which is what Russell 2 applies to, and gully erosion. So if we look at, I apologize here for moving this around on you, but the general location of the landscape, sheet and rill erosion occurs on side slopes, right? Whereas swales or drainage ways, natural or man-made, where runoff water concentrates. When we have water concentrating in the landscape and it has the energy to start scouring or carving, that's where gullies happen, okay? And again, sometimes the differences between those parts of the landscape are subtle. But remember, side slopes, what we might call overland or sheet flow areas, and swales, that's what differentiates them. And you remember that I talked about this idea of detachment, right? A three-part process: detach, transport, and deposit. It's very important to understand the cause of detachment, and that will help us solve the erosion problem in question. So right here, the fundamental cause of detachment in the sheet and rill erosion process that starts the process, gets the genie out of the bottle, is raindrop splash, right? Now, it's the sheet flow as water moves, flows across the side slopes. That sheet flow moves detached particles. But I will show you, hopefully a moment here to show you a video where if you don't have raindrop splash, you're not going to have much sheet and rill erosion. Now, as the landscape form, comes together, right? Different hillsides come together, and we have drainage ways where water starts to concentrate. We have concentrated flow, and that the key difference between sheet and rill erosion and gully erosion is that the water in these drainage ways or swales in the landscape has enough energy to detach particles, and it starts cutting. Okay, so we're going to have a fundamentally different strategy. We want to intercept raindrops to stop sheet and rill erosion. Right, that's our main. We want to intercept raindrops, whereas the gully erosion, we want to not just try to reduce the amount of water that's coming into the drainage way, right? So we want a better infiltration and better raindrop interception uphill, but we may need to do something more in the drainage way itself. We have to armor it with sod, sod waterways, something like that. So, that's the last thing here on the chart, and then I'll show you some pictures, is that sheet erosion is essentially invisible, right? It's just the removal of a sheet of soil. I'll show you some pictures of it. Rills are visible after they occur, but if you just run a disc or some other tillage tool, you're not going to see rills, and they don't come back in the same place. Meanwhile, gullies, they're certainly visible after they occur. The difference between an ephemeral gully, right, and a classic gully is that an ephemeral gully is shallow enough that you can till and cover it up. A classic gully you're not going to farm over, and because gullies are their location is defined by the landscape, right? Gullies will always come back in the same place, while sheet and rill erosion and rills won't come back in the same place. So, guys, that was my tour of this document, but I hadn't made a blow up of this page, so I wanted to do that. And now I can just take a few minutes and just illustrate this sheet and rill erosion process. I mentioned that it really starts with the raindrop, right? That raindrop detaching soil from aggregates, pounding the soil. That's the detachment energy that we need. And we have that, once we have that detachment, what happens is the first layer of water, right, goes into the soil sponge, but those pores get blocked up by that first layer of detached particles. And so once we have this puddling effect, if we have any slope at all, and then we start to have water move, downhill. And this importance of the vertical falling raindrops in causing erosion is illustrated here. These are probably clay, little chunks of clay. There might be a rock or two, but these pedestals, they show us that if we don't have the vertical impact, right, of those raindrops to detaching soil, then we don't have erosion. So clearly, sheet flow, water moving, in a sheet across this slope here downhill, is not doing a lot of the detachment. It's just carrying away what the raindrops detached. And we have, again, another example here on the eastern shore. There's a shell, and you can see my pen. And so there's certainly more than a dime's worth of thickness, at least in this spot. But again, if that reference point wasn't there, if that shell wasn't there in that pedestal, we really wouldn't be able to tell how much soil might have been lost from whatever rainfall events did this. Showed you this picture before. Again, if we didn't have these reference points, these little rocks standing up on their own, we wouldn't know that a whole sheet of soil was removed from this part of this tray, and then, as we see, deposited down here. Another example, right? Hey, the evidence of sheet erosion is the absence of soil. The evidence of erosion is the absence of soil. So here in Withville was a soils erosion training we did. I don't think that the farmer originally poured this concrete like this. I think the soil level was higher, but we have to be an erosion detective, and look for that. As water, starts to flow, micro topography will cause these little wash patterns, right? So we start to see these wash patterns, and these are rills, right? We're not just losing soil in a sheet across the field. We also might start to have these patterns develop, but it's certainly not because the landscape is concentrating the flow of water, right? And so this is a classic image. It's not actually from this country, but it's such a good one, I use it anyway. Rills tend to form parallel to each other, and again, it's in that table on the second page of those charts that I showed you. You can catch up with it there, but rills tend to be parallel to each other across the slope, right? And you can see this is a side slope. We certainly aren't having the landscape concentrating water here. So we have what we might call sheet flow. And remember, on side slopes, detachment is primarily caused by the raindrop impact. And yes, there's a little bit of carving happening in these rills, but it's actually, these rills would not be happening if we didn't have raindrop impact, right? Because that's what starts sealing up the soil in the first place. And it's another image here. So those are also rills parallel to each other. But once we get into a landform like this, we certainly have side slopes, but you can see the water starts to concentrate. This is not in Virginia either, but as water concentrates, it's going to start picking up energy, and that's where we can start getting some cutting going on. So here's an image just to illustrate an ephemeral gully. This is from Steve Groff's, and you can see it's a long time ago, but I kind of lifted these images from, you see there's like an S-shaped grass thing here. I guess it's supposed to be a grass waterway, but it doesn't look like it might be doing its job very well. But remember that S kind of shape. So here's a rain event. And I guess it kind of made a mess, because that same S shape, you can see there's a power pole, but guys, the landscape here is a little bit hard to tell. Clean till field, there's obviously some meaningful slope here. Water gets concentrated, and tends to run in this same pattern. So the idea is that when the landscape is concentrating the flow, we're going to have the cutting's going to keep coming back in the same place. So, they smoothed it out, probably planted some grass, put some straw bales in there. Gully keeps coming back, right? Same place. This is an ephemeral gully, right? In the sense that it is a gully. It's not a rill. It may not be very deep. We can till over it, but it's an ephemeral gully, and it's going to keep coming back here unless we armor this better, or we stop so much water from coming down, and probably need to stop doing this much tillage and have some more cover. And there you can see ephemeral gully in action, right? This is a concentrated gully, a classic gully, and the water that can be concentrated by man-made features. Here's a gully along a road, right? The road is helping concentrate the water and do the cutting. And we can also, sometimes it's the roof or the yard, the farmstead where the water's, collecting and running down, and that contributes to a concentrated flow situation. And in pastures, they can be very, very prominent. And this is a pasture in King William County, an incredible gully in a pretty much abused pasture situation. We even get blowouts on the side of fields. This is a little different, but again, this is a field edge blowout where the whole edge of the field kind of slumps off. This is not sheet and rill erosion. I call this concentrated flow. We have water just pouring over the edge right here, and then it just undercuts. So, and they can get pretty deep too. This last diagram here highlights, and we'll get into this in the next webinar, this idea that the landscape needs to be divided up into areas that are subject to sheet flow and sheet and rill erosion versus subject to concentrated flow. And so when we start determining where does Russell apply, Russell only applies to side slopes. And so what I've done in this image is just showed you how, there's a road here, there's a swale here, there's obviously a swale here, a swale here. If you look at this image, right, there's some swales. Well, in that area, Russell 2 is not going to apply, because the research that was done to create Russell, it was only done experiments on side slopes. And so the first step in knowing where else to apply is splitting up the landscape. But it's not because there's no erosion in the concentrated flow areas. It's because that form of erosion we need to assess with our eyes, right? And not with raw. Here are my conclusions. Wind and sheet and rill erosion, they're a key cause of soil degradation. They're very hard to see and measure in the field, right? Wind and especially sheet and rill erosion, they take a uniform layer of soil off, and concentrated flow, gully erosion, much easier to see in the field, and they're not on the same parts of the landscape. So I have a short video I was going to show you, and I've run out of time. But for those who want to stick around, I'll probably show this short video that shows you the difference between sheet flow and raindrop impact in terms of their ability to detach soil. And this question is a follow-up to that video, but I already answered this question for you before. But let's go ahead and have you, just to finish today, those who are still with me, go ahead and answer this question. If you would, we'll talk about it. And then if you want to stick around, I'll show you the video to help reinforce why the answer is what it is. So we're right at 50% participation, and most you're getting the answer wrong, okay? And I think maybe that highlights why, for those of you who said it was true, you should stick around and watch this video for a few minutes, okay? Because you said true, but that's not right. It's not right, y'all. The primary cause of detachment, all right, highlight, is raindrop impact. If you don't have raindrops hitting bare soil, you're not going to have much sheet and rill erosion. Now, so this is wrong, and therefore it is false that support practices, right, such as strip cropping, contouring, and terracing, which again we might not have discussed, and you might be like, oh, that's not fair, Chris. That's not the starting point for agricultural erosion control in Virginia for sheet and rill. Okay. The right answer is false here, because we need to intercept raindrops. We need to cover the soil. And if we change the shape of the land, but we don't cover the soil, we're not getting there. And so given that anyone who answered true, stick around and watch this video. What you're looking at is a rainfall simulator, right? And you're seeing this tray of bare soil. When we have raindrop impact, right, it is dislodging, it's doing the detachment. It takes a lot of energy, relatively speaking, to break apart aggregates, even a soil like this one that's heavily tilled and it's bare. And what you're seeing is there's not that much runoff, but what is running off has plenty of detached sediment in it, right? Y'all agree? Okay. So what Lydia and I did, and JB Daniel, who filmed this for me, what we did is we took this same tray of soil, and instead of raining on it, we just did we put water on it in a sheet, right? We did sheet flow, as you might expect to see, because look, there's sheet flow coming off of this right now. Water's moving down. There's no concentrated gully in here or drainage way. Water's moving down. There's not that much water moving down. I'm telling you, if you don't have the raindrop impact, then you don't have the detachment, you're not going to have much erosion. Well, prove it to me, Chris. Come on, show me. Okay, so here's what we did in contrast to that. We use this tray and this watering can to put a very large amount of water on here, but you see how it's hitting in a sheet. There's a lot of overland flow. There's not a lot of detachment happening. So I'll try to let you prove that to yourself by looking at the color of the water, right? And what this is telling us is that this is why, if we don't cover the land and stop the raindrops, especially the raindrops during the big violent events, we can stop this overland flow all day long. It's not going to fix the problem. And so that's why the answer to the question, the review question, was false, because it said the starting point was, you know, contouring, right? So let's just farm on the contour and throw up maybe, you know, so the contouring would do this. It would create little ridges, right? Which would slow this water movement, right? Create ridges. No. Create cover, intercept the raindrop. That is the foundation. And the rainfall simulator really does a good job of showing that. And hopefully that helped you. And so when we get into Russell, what you will see is that if you put in contouring, right, it's not very beneficial for sheet and roll rate folks. That is my story. Thank you for sticking with me, those who did.